All 3D printing is essentially a layer by layer process. So we start with a virtual model, and we get that either through a 3D scan, or we can use like medical MRI data, or we can, which is what we usually do, go through a CAD package and create a virtual CAD model. For the metal side, it's a lot more complicated. The layer by layer process is still there, but instead of using plastic and squirting it out of a nozzle, now we're using layers of metal powder and a laser to melt them together.
We have this really awesome metal printer. It's the Renishaw AM400. It's, in my opinion, one of the nicest machines that we can have for metal printing. You don't have the limitations of traditional machining anymore. So creating what are called topology optimized structures, where you can take apart and remove any non-critical material, so you get very light parts, but also very strong parts. There's both science in it and there's art in it. So the science part is, you're taking this material that's extremely fine. You have to worry about it flowing properly into the machine. You have to be worrying about how much heat you're putting in and taking out, what type of surface finishes you're going to get. But then it also comes down to how you're designing the parts. We traditionally think about designing our parts for more traditional machining. When you come over here, all of a sudden a lot of those things can actually work against you.
We've had additive at Lehigh for 15 years. The addition of metal printing is a huge leap for us. It allows us to print things in metal, but also to do amazing research. The wonderful thing about having it here in the Wilbur Powerhouse is that we're agnostic when it comes to departments and programs, right? So it goes across colleges. If we have young entrepreneurs who have an idea and the only way that they can make that come to a reality is to print in metal, they will have the ability to do that here.